Hey, this is Professor Perez from Saddleback College. Today, we're going to work on square roots. Don't get scared. Anyway, before we get started, we got to get Charlie out. He better be ready to go. Hey, Charlie, ready to go? Yeah, we're doing square roots today. That's right. These problems are radical. Anyway, let's get started here. Right there. Okay, pay attention, Charlie. What number do we square to get 16? 4. That's right. You just did a square root. What? Anyway, well, pay attention, Charlie. If somebody asks you, what number do we square to get 16? It's 4, because 4 squared is 16, but it is also negative 4, because negative 4 squared is 16, right? Okay, now let's talk about the square root. What is the square root of 16, Charlie? Well, watch this. We have a 16 and we have a radical symbol there. That radical symbol with the 16 underneath is saying, what is the square root of 16? So, when somebody asks you, what is the square root of 16? You're thinking, what number do you square to get 16? And it's 4, right? But we also saw that negative 4 squared equals 16. Well, when you use a radical symbol and say, what is the square root of 16? We give what we call the principal root, which is always positive. One thing to remember, whenever you take the square root of a number, the answer will always be positive. So keep that in mind. Okay, so the square root of 16 is 4, because 4 squared is 16, Charlie. All right, let's look at some other square roots. Now, before we move on, though, let's look at what we call perfect squares. Now, watch. Charlie, what's 0 squared?
0.
0, that's right. So 0 is considered a perfect square, which means when you're asked, what is the square root of 0? The answer will be 0, because 0 squared is 0. It's so easy, it's confusing. Now, watch this one, Charlie. 1 is a perfect square, because 1 squared is 1. Therefore, the square root of 1 will be 1, right? You gotta think about that one. Now, here's this one. 4 is also a perfect square, because 2 squared is 4. Therefore, Charlie, if somebody asks you, what is the square root of 4? What's the answer? 2. 2, that's right. And other perfect squares are 9, because 3 squared is 9. We have 16, because 4 squared is 16. 25 is a perfect square, because 5 squared is 25. And 36 is a perfect square, because 6 squared is 36. And of course, there's a whole lot more, right? We'll stop there for now. All right, Charlie, let's do some problems. What is the square root of 36, Charlie?
6.
6, because 6 squared is 36. Remember, square roots, we always give positive answers. The principal root. Okay, Charlie, how about the square root of 49?
7.
7, because 7 squared is 49. Now, Charlie, what's the square root of 144?
12.
12, because 12 squared is 144, right? Okay, we're dealing with perfect squares here. Charlie, what's the square root of 64?
8.
8, because 8 times 8 is 64. What's the square root of 100?
10.
10, because 10 squared is 100. Now pay attention to this one, Charlie. Don't get scared. What's the square root of 10? That's right. 10 is not a perfect square. Therefore, we have to use a calculator. Now, the square root of 9 is 3, so the square root of 10 should be a little bit more than 3. And Charlie, if you take your calculator out and calculate the square root of 10, you will get a number 3.162, which is a little bit bigger than 3, right? In this class, at this time, we're only going to deal with square roots of perfect squares, okay? All right, now Charlie, we're going to look at what we call a right triangle, okay? This is a word problem. Now, a right triangle means it has a right angle. And the side length opposite the right angle, which is that 13, Charlie, is called the hypotenuse. And the 5 and that A are referred to as the legs of the triangle. Now, when you have a right triangle, we have a theorem, which is called the Pythagorean theorem. And it's only applied to right triangles like this. And that theorem is up there. C squared equals A squared plus B squared. Now we're going to use that theorem to solve for that side length A, right? Find that side length A, okay? Now, In the theorem, C represents the side length opposite the right angle, which is called the hypotenuse, the longest side. The A and the B represent what we call the legs of the triangle. And here we have it labeled there. The hypotenuse is 13, Charlie. The legs are 5 inches and A. And we're trying to find A. So here we go, Charlie. There's the theorem. C squared equals A squared plus B squared. Our C is at 13. Our A is that leg right there, and the other leg, we'll call it 5. Okay. Now, Charlie, what's 13 squared?
169.
That's a tough one there. And 5 squared is 25. Very nice. Now, we're going to solve for A squared. And so, what do we do?
Subtract 25.
That's right. And so we get 169 subtract 25 is
144.
144. That's right. And on the right-hand side, we're left with A squared. So 144 equals A squared, Charlie. So, Charlie, what number do you square to get 144?
12.
That's right. So 12 should equal A. Well, if 12 equals A, that means A equals 12. And so that's our missing side length. And you can see, if you take 12 squared, which is 144, plus 5 squared, which is 25, you'll get 169. And if you take the square root of 169, you get 13. So the theorem does work. That's a tough problem there, right? Okay, we're going to do more of those later. Anyway, let's do some square root problems now. Here we go, Charlie. The square root of 4 plus square root of 9. We don't need calculators for this. What's the square root of 4?
2.
And the square root of 9?
3.
And what's 2 plus 3?
5.
Very nice. Okay, here's another one. Square root of 16 subtract square root of 25. What's the square root of 16?
4.
Square root of 25?
5.
Very nice. What's 4 subtract 5?
-1.
-1. No calculator required. Let's do another one, China. Don't get scared. 3 square roots of 64 means 3 times the square root of 64. 2 square roots of 49 means 2 times the square root of 49, Charlie. So, we have 3 times, what's the square root of 64?
8.
8. Plus, subtract 2 times the square root of 49, which is
7.
7. There we go. And 3 times 8 is
24.
2 times 7.
14.
And 24 subtract 14
10.
is 10. Very nice there, Charlie. All right. Let's do one more. Now, don't get scared. Notice we have fractions underneath the radical sign. So, what fraction do we square to get 25 over 9, Charlie?
5/3.
That's right. A lot of people like to think, well, the square root of 25 is 5, and the square root of 9 is 3, so that is 5/3, right? Because 5/3 squared means 5/3 times 5/3, which is 25 over 9, right? So the square root of 25 over 9 is 5/3. What's the square root of 81 over 16, Charlie?
9/4.
Very nice there, 9 over 4. And here, we have to find the LCD, which is
12.
Okay, now we're going to use some kung fu. Remember, I'll work this one for you. 3 goes into 12 4 times. 4 times 5 is 20. 4 goes into 12 3 times. 3 times 9 is 27. And remember, it's over 12 because these are 12s. And 20 plus 27 is 47, and it's over 12. That's our answer, 47 12s. That was some good kung fu there. Now notice, we did all these without a calculator, right? So anyway, you better be ready to do these without a calculator on the next exam. Anyway, that's it for now. We'll see you again soon.